This is Jennifer Martinez. In this video we're going to look at a percent decrease application problem. Percent increase and percent decrease application problems turn out to be exponential formulas. I will show you why in a few minutes, but for the moment let's go ahead and write down our formula for exponential, and then I'll explain why in this case it's an exponential function. So we have this. Y equals CA to the X is our exponential formula. Y represents the number of cars. Because that's what we're looking for, how many cars, or how many years will I have so many cars. And let's let X be the years, the number of years. So it's better to let the X be the number of years. Okay. C is usually the initial amount. And A, well, A is usually the growth, or in this case, the decay factor. But if they're not giving us, they're giving us a percent increase. So if it's a percent decrease, it's 1 minus R, where R is the percent, or it's 1 plus R if it's R is an increase. Percent 1 minus R if it's a percent decrease, 1 plus R if it's a percent increase. So again, that's what it's equal to, where R equals percent decrease in this case. Okay, so we have Y is equal to the initial amount, you know, is 72. A and C are constants. X and Y are variables, so we don't have to find those. A, we do have to find that, so that would be 1 minus 0.02, because 2% is the percent increase. This one is given to, that's 72. And then we have raised to the X. This can be simplified to 72 times 0.98x, or 0.98x if you would rather. Okay, let's look at Y. I'm going to stop there for a moment, and with the problem, and let's go for Y for a few minutes. So I'm just going to make a chart and think about this logically, X and Y. So at year 0, when we're first starting out, we have 72 cars. Now, it's decreasing by 2% annually. So what happens 1 year later, we're going to figure this out by saying it's going to be 0.02, that's the 2%, times the 72. That's how much it's decreasing. But it started with 72, so our new amount is going to be 72. There's where the minus comes in, times 0.02 times 72. Now, where are they getting the 0.98 from, or the 1 minus 0.02 in the formula? Well, we're going to factor out a 72. We're going to have 1 minus 0.02, and that will be the next equation, which, by the way, is 72 times 0.98. So you can see here, whatever that answer is, I don't even care about multiplying it out. When you get a 1 here, you do get 72 times 1.8. And if you repeat this process, right, because now we know the next year. What happens the next year? Now, this is more difficult. We don't start with 72. Now we start with 72 times 0.98. Well, let's figure out what that is. It's 70.56. So to get this answer right here, we're going to do the same thing, but 70.56. We're going to subtract that by 0.02. So again, you might want to think about it first. 0.02 times the 70, that would be the amount of decrease. You got to subtract that from the original. Again, we're going to factor out that 70.56 and get the 1 minus 0.02. Excuse me. Factoring out 70.56, you see here, that's where you get the 1. There's where you get the 0.92. So this value right here, we know is 72 times 0.98. And then this one right here, we know is another 0.98. So then you get 72 times 0.98 squared, which, by the way, if you plug in a 2 here, that's what that would be. So you can see that the growth factor, we're multiplying 0.98 times every time. So that makes sense there, and we're starting with 72. So that's where this formula comes from. Okay, That was extra. We can actually even erase that. I'll leave it on the side. We don't need it. Let's go and now answer the question. The question is, so I'm going to erase this. The question actually asks, in how many years, so if I have X and Y, in how many years, that would be the question mark, will we have 43 million cars? And since Y is the number of cars in millions, I didn't write that down, but it is in millions, we could just put in a 43. Okay, so we have 43 here. We're going to plug in for Y now that we have our formula. And we are going to solve for X. How do you solve an exponential function? Well, you got to get it out of the exponential functions and put it into logs. Exponents are logs. So first, I would like to divide both sides by 72 to isolate that exponential function. So what we have here is 43 over 72 equals 0.098. Oops, sorry, too many zeros. 98 to the x. And then what we can do is take log of both sides. So let me go ahead and do that over here. Log of the left equals log of the right. And then on the right side, I can bring down that x. That's one of our properties of logs. And then on the right, nothing, or left, nothing changes. So I'll just rewrite that. Finally, I'm going to divide both sides by log of 0.98. Log of 0.98. To get that x is equal to, which if we plug that in on our calculator, that is approximately, well, it's 25.514699, and they ask you to round it to the nearest year. So to the nearest year, it would be 26, because the 0.5, and it's 0.5, you round out, that's a little closer than 26 than it is 25. And that's how you solve this exponential percent decrease. If you had a percent increase, the only thing that would be different is this would be a plus instead of a minus. Hope that helps.